Hello, welcome to another example of a med that is being titrated or adjusted. Again, as I read through the problem, I am going to try to categorize or make sense of the information and fill it in with the questions below. So your patient is a 150-pound woman who is 5'4". So I'm going to put all of that information under patient info. So 150 pounds, female, 5'4". All right. The attending physician has ordered this med 8 milligrams in 250 milliliters of D5W. So that is my dosage strength. So 8 milligrams is in the IV bag. The IV bag is 250 milliliters. So I will use that as a conversion in my dimensional analysis. And so I'm right here now. To infuse at 5 micrograms per minute. So that's part of the order because it was saying the physician has ordered, and all of this is part of the order. So the ordered dose is 5 micrograms per minute. To maintain systolic blood pressure above 100. So that's my physiological effect. Systolic blood pressure has to be greater than 100. The normal dosage range for this med is, so I'm going to include that, this is the ordered start. And then next I'm going to include the range because I know they're going to ask me about that. And so I like to just note that right away. So 0.5 mcg per minute up to 30. So really huge range there of that I can adjust the med. And I see with this med, with us starting at 5 for the ordered start, like we could definitely adjust up or down as needed because we're not starting at the minimum on this particular med. So then it says the standard protocol is to titrate this med by 1. So I'm going to make note of that too. I'm going to use the word adjust because that just helps with my cognitive load. I know titrate means adjust, so I'm putting it here as the adjustment by 1 microgram per minute. And that's every 5 to 10 minutes. So I cannot adjust every minute. This microgram per minute means I would add that to what was ordered. And that could happen either 5 or 10 minutes after my last adjustment. So I've made sense of all the information. And now I look at my first math question, and it's normal minimum. And on the last problem, my first thing I did was convert the weight to kilograms. But as I wrote everything down here, I noticed kilograms was never even mentioned. So I don't need kilograms. If you converted the weight to kilograms, you can include that in your patient info, but we're not going to need it in our dimensional analysis this time. Normal minimum is my first math question. And so I go to my range and I pick the minimum, 0.5 mcg per minute. So I don't have kilograms as part of that label, so I don't need kilograms as part of my dimensional analysis. So it does not matter if you work with micrograms or with minutes first. I'm going to work with micrograms. I know that there are 1,000 micrograms to a milligram. And I did that conversion because when I wrote down the strength, it was in milligrams. So next thing I'm going to do is pull in this strength. And I need the 8 milligrams to be on the bottom to cancel. I need the 250 up top because they're in the same bag of IV fluid. And that got me to milliliters, which is one of the things I want to keep. So then I have to go back to start. The other thing I need to convert is minutes. Minutes will have to be on the top. I want hours, so I'll use 60 minutes on top is 1 hour. And minutes cancels because they are top to bottom. So I'm ready to do the math. I am doing dimensional analysis, so I multiply straight across. So 0.5 times 250 times 60 gives me 7,500. Across the denominator, 1,000 times 8 gives me 8,000. And I will divide them out. And I get 0.9375. This is really tricky rounding because normally when we're less than 1 milliliter, we'll round it to hundredths, which would be 0.94. However, our IV pumps don't let us go to hundredths. So because this is a milliliter per hour rate, I am going to round it to tenths. And if you look back on your content guide for this week, it tells you to round to tenths. And if you would have something tricky like this, where sort of two rounding rules are competing for which one is correct, I will give you directions because you're not yet in practice. So knowing that the pump can't take hundredths is a lot to ask. So now it asked me for the normal maximum. And so I might be thinking, oh, I do a dimensional analysis again, but there's actually a shortcut. And that shortcut is to know that the dose and the rate are proportional. So I'm going to make a proportion out of dose over rate. I want to go back and just make note of what is my dose and what is my rate and what labels are on them. So dose is what's ordered here, and or from the range, dose is the whole way in that ordered part with micrograms per minute. So that is dose. And here in the box, this guy is my rate. So rate has the label of milliliter per hour. Dose has a label of microgram per minute. So maximum dose is from the range, which is up here at 30. So I'll put that on top. And maximum rate, I don't know, so I'll put an X. Well, I have to have that equal to something. So this is where I can bring in the minimum. So the minimum dose is 0.5. And that is equal to a minimum rate of 0.9 because we had already figured those out. So that gives me a proportion to equal fractions. On the previous example, we started with the minimum first. Here, I just got ahead of myself and started with the maximum, and then I filled in the minimum second. So when I cross multiply, I have 0.5x. Multiplying on my other diagonal, I take 30 times 0.9, and that gives me 27. And then I divide by 0.5 on both sides. And I get X as 54 milliliters per hour. So that means I'm going to be able to adjust my IV pump anywhere from 0.9 up to 54, and I would be within the range that is approved for this med. Finally, they asked me for the initial. And so the initial is this order. This is where I'm to start. I'm supposed to start at 5. So again, I'm going to use the idea of dose over rate. I'm going to start with my minimum as a known pair of these values. So 0.5 over 0.9. And then I'll fill in that ordered dose of 5 and put it over X. Now, this is another one of those that you may immediately notice a pattern. We went from 0.5 to 5, so that is a times 10. And so that would take us from 0.9 times 10 to X equals 9. And so if you notice that pattern, absolutely use that to shorten your math. If you don't notice the pattern, you can use the cross product. So 0.5 over 0.9 equals 5 over X. Multiply diagonally, so 0.5x is equal to 0.9 times 5, which is 4.5. And then divide by 0.5 on both sides, and we get X equals 9. So we get the same answer either way, if we notice the times 10 or if we do the math. So now I'll move on to the chart of values that I'm supposed to fill in as this patient has their IV meds adjusted. So in the ordered dose, the initial dose was 5, and that was micrograms per minute, no kilograms in there. Systolic blood pressure, this is going to be measured in our clinical setting. And the milliliter per hour rate that we just calculated going with the 5 was 9 milliliters per hour. The whole way down through my chart, so here we have an interval of 5 minutes, Then we have an interval of 10 minutes. Then we have another interval of 5 minutes. And these are all reasonable adjustments because it was to be every 5 to 10 minutes. We also had that our adjustment, we were to titrate by 1. So I'm going to fill in this whole column because it's just so easy. Adjusting up, so I'm adding 1. So this would be 6 micrograms per minute. Up again, so adding 1, so 7. You've got the pattern here. 8. And 9. So then I need to figure out my milliliter per hour rate for all of these, and we use that same concept of dose over rate for all of them. We always start with that minimum, so my minimum dose was 0.5 with my minimum rate of 0.9, and I'll put in my 6 and my X, and I'm just going to go down through and set up all of these. So my next one is 0.5 over 0.9 is 7 over X. And then I have 0.5 over 0.9 is 8 over X. And finally, 0.5 over 0.9 is equal to 9 over X. I'm going to go through and do the cross product. So 0.5 times X is 0.5X is equal to 5.4. And then 5.4 divided by 0.5 gives me 10.8 milliliters per hour. So one answer. Going to the next one. Multiplying on the first diagonal is 0.5x. On the second one is 6.3. And so 6.3 divided by 0.5 gives me 12.6. And I continue. So 0.5x equals 7.2. And then divide by 0.5, and I get 14.4 milliliters per hour. And final one, cross multiply, 0.5x equals 8.1. Divide both sides by 0.5, and I get 16.2 milliliters per hour. So utilizing the shortcut of the proportion over and over again to figure out what that milliliter per hour rate is for this patient.